Hello, everybody, and welcome. We're happy to have you joining us through this Google Hangout on Air. I'm Lily Talcott, working at the Ithaca City School District, and with me, as always, is
Liddy Coyle. I'm working with Lily on doing our district-level professional development.
Thanks so much for coming today. Our title for today's session is Engaging Mathematics, Strategies for Getting Students Thinking and Talking.
If you're an educator that uses learning targets, you might think of this as your target for today. I can use information from today's panelists to reflect on my current mathematics instruction practices.
Cool. If you want to comment at all today on the broadcast, or if you have any questions for our panelists, if you're watching it live, or even if you're watching it later and you want to submit a question for us to get to later, that's totally fine. You can do that by simply clicking on, if you're in YouTube, just clicking on that spot right below this video where it says add a comment, so we'll be checking that throughout. You can also add a comment through Google+, so the link that we sent out to you all. You can simply click on that and you can click the say something or share what's new and just type your question that way. Today we're going to be speaking in generalities, and speaking of students, don't worry, we will respect confidentiality.
Yep. And also, we're really grateful to the panelists for sharing their experiences. However, we don't know the audience's students. So if you're out there and listening in, we are sharing examples and personal stories of effective mathematical instruction. But please use your data and work with your PLC to create the most effective intervention to meet the needs of your students. And we're going to start right out, and let's do some introductions. Panelists, if you would introduce yourselves. Chris, you want to start?
Yes, Christine Barley. I'm an educator at Beverly J. Martin School. I currently am doing a 4-5 loop.
Thanks. And Jane?
Hi, I'm Jane Kessler. Currently, I'm a teacher on special assignment. I'm spending 3 days a week doing math intervention at Enfield Elementary School, and 2 days a week doing all sorts of assorted district mathematical tasks and projects and so on.
Great. Julie?
Hi, I'm Julie Humble. I am currently an instructional coach at South Hill Elementary School, working with all teachers.
Thanks. We're happy to have you ladies here with us today. So today we'll be talking about specific strategies for making mathematics engaging. We'll get to the heart of instruction in just a moment, but we're going to back up for just a little bit first. So let's have our panelists talk about the structures of their classrooms. What are some of the ways that you set up your math block to maximize student learning and engagement? And Julie, we're going to start with you and then pass it on to everybody.
Okay, so am I just answering that one question right now, or?
Yes.
Okay. So when I start out math, I work into the structure of math from the beginning of the school year, starting out with the first 6 weeks of school. And I do a lot of whole class activities. And once the kids get to know the materials and get to work around the classroom and know their way around, then I work into a daily structure, usually having a daily 3 structure, which is similar to the daily 5 ELA structure. And it allows kids to have academic choice and also work in small skill-based groups.
Great. Julie, can you talk a little bit more about how you set that up and what the what it looks like, maybe what the different centers are called?
So when I move into the dailies, it really starts out teaching the kids what the choice options are. At the kindergarten level, it usually stays pretty simple. We usually have a math by myself, which can encompass many things in mathematics, and then math games and math with technology. The other areas that may be incorporated if you did this type of math structure would be partner math, math writing, or maybe paper practice. So there's a bunch of different things you can incorporate. So it is set up where the children build stamina during these centers, and they start out working with short periods of time on simple activities that they can be successful at. So they know what the expectation is at the time. I start out from 5 minutes to work up to 20 minutes so that they can be independent and I can work in small groups and they don't need supervision from an adult throughout that time. It usually takes probably 3 weeks to set this up with the kids. You still are doing math instruction because while I'm doing dailies and kids are working in small skill groups, they are still getting access to the Common Core at different times of the day through morning meeting or in the afternoon through choice time and areas like that. Is there any other questions? Did I answer everything you just asked?
I think so. Yeah, I think that's helpful. Jane and Chris, could you talk a little bit about how you structure your math times?
So because we're a loop, and this year we had 5th graders, we did something a little different with our cohort of students. We have 3 general education teachers and 2 special education teachers who are assigned to work with the grade level, and we did skill-based grouping. So each couple chapters of a unit, or depending on the length of a unit, or a whole unit, we would pre- and post-test based on specific skills, and then we would group the children according to what skill set they had. Keeping in mind that we wanted the teachers to rotate and teach all levels of groups of kids, that the groupings on new content were heterogeneous, they weren't homogeneous. We were able to then get 5 small group instructional cohorts going at a time. What it forced us to do as professionals is talk about the kids all the time, meet and group them, and really be able to focus in on those learning targets and what kids were able to do and what kids couldn't do yet, and then have active conversations and active interventions on helping kids master the things that they couldn't do, which was different for us. It was, again, we had a lot of meeting time. We had to really make sure that we were on the same page. Units were planned out. We got to discuss as professionals a lot of the teaching strategies, what's working for you teaching adding and subtracting fractions with unlike denominators, what's working with you for teaching mixed numbers. And we shared materials, resources, ideas, and whatnot. So we felt it was pretty powerful this year with this cohort of children, and the professionals we had working with them are anxious to do it again. Time-wise, we devote an hour first thing every morning, and then we use our Core Plus time as also math, a math-focused time. So all students during that Core Plus time, if they are getting pulled out, we ask that it be a math focus. So about an hour and a half of math instruction a day.
That's great. Sounds like you guys have really maximized that time for sure. Jane, can you talk a little bit about, I know you are, you're not a classroom teacher this year, but you structure it and you see actually a lot of different structures yourself, and you have many years of experience yourself setting up your math block. So could you talk a little bit about either your own experience or some other experiences that you've seen?
Sure. One of the things that I found really important in creating a structure is for the kids to have certain routines that they become very adept at. And whether I'm doing a whole class lesson, with my 5th grade, I would often start with what I would call a quickie, which would be a computational review of some sort, followed by a problem of the day, which really emphasized problem solving. And
please. Thank you.
Oh. And
we're in real schools, everyone.
Yes. And I would try to make whatever problem we were looking at accessible, so all children could have some sort of in to the problem and get to struggle with it and figure it out. And part of our learning experience would be discussing it together. Also, in order to do any type of small group work, I would have some whole group experiences first, where I would teach the students certain routines of how they, for example, use technology in small groups if we were breaking up the group, or some other independent activities. So I think the routines are really critical to really not losing a lot of time with your transitions and keeping the kids engaged during your math class.
Yeah, that's great. That's great. Liddy, did you have another question that you wanted to ask, a little follow-up?
Yeah, I just wanted to be sure that we are clear in a really important piece of the structure that Julie was talking about, was that the students are doing that small group independent practice that's really meaningful, in addition to going to work with the teacher, so that the teacher is not one of the rotations or one of the choices, and that frees the teacher up. And Julie, you can correct me if I'm wrong.
Yeah, sorry.
Frees the teacher up to pull students at whatever level she needs, so she's not tied to one group of kids coming to her at one time.
Right. So in the structure, with the 3 choices, it's giving the kids academic choice to do something while they are not working in a small group or individually. So they would be working on skills that they've already learned and playing games that they've already learned to keep working on their math skills. And in the kindergarten classroom, we have more than one person usually who is pulling small groups, so it's usually half the class that would be making that academic choice or working with their peers independently. And then they would swap, and they would go to group, and the other half of the class would get to make those choices. So at the primary level, it does look a little different than it might at the intermediate level.
Thanks.
Was that better?
That was helpful. Thank you.
Okay. So we know one of the keys to developing a deep understanding of mathematical concepts comes from students talking about and discussing their thinking. We'd like you all to discuss some strategies for helping students talk productively about mathematics. Jane, would you lead us off in that discussion?
Sure. There's lots and lots of different activities you can do within your classroom, but I want to focus in on one strategy that I've really been spending some time with this year, which is number talks. And number talks are a wonderful way of engaging students that encourages thinking about numbers. They are short, regular routines. They provide practice with computation. You use number relationships to add, subtract, multiply, or divide. And it's really important to understand it's not a direct teaching time. Instead, it's a time that students are applying their knowledge of math strategies, and it's a time where they're learning from one another. The goal of doing a number talk is computational fluency, and you're striving for really accurate methods of computing. It's a lot more than just learning your basic facts. So this winter and spring, with Ann Karen, who's a retired ICSD teacher, we met with teachers from 4 schools in a number talk study group. And we used this particular book, let's see if you can see it there, by Sherry Paris. It's called Number Talks, Helping Children Build Mental Math and Computational Strategies. It's now in the libraries of those 4 schools as a resource. There's also some helpful websites out there. I wanted to give you a better idea of what a number talks looks like by actually sharing some examples of talks that I've done with students. The routine involved in a number talk is pretty basic. A teacher presents a problem, and it can be with 10 frames or dot cards or within the context of a word problem, or it can just be an expression like 13 plus 8. Then the students figure out an answer, and you usually have some sort of signal for them to indicate when they've got an answer. I use a thumbs up signal, so children put their fists to their chest and just put a thumb up when they've got an answer. Then we have them share those answers out, and we'll get all of the different answers that are there, and I'll keep saying, well, is there a different answer? And often you'll get quite a variety of answers reflecting the children's thinking. Then comes the really interesting part for me, is we have the children share their thinking. Now, one alternative is you can have them do a pair share first. I've been mainly doing whole group sharings because some of my groups have been pretty small in the first place. But then they get to basically explain how they got their answer. Finally, the class is going to agree on what the actual real answer to the problem is, and then you might repeat the whole set of steps. So I was going to share with you an example here. I can find it. Let's see. Okay, this first picture I'm showing you is an example of an addition problem. And
Yes, it looks good.
Okay, there it is.
You right there, Jane. You're there.
Okay, I'm in the picture. It's hard for me to know if that was working or not. But let me tell you a few things about this picture. This is based on the problem 9 plus 5 plus 1. And what you'll notice in here is you'll see lots of different strategies on the board beside me. Since this was taken near the end of the talk, you only see one correct answer, 15 on the board, but in the beginning there were quite a few answers that we actually worked through. You'll see a student has answered it, and I used a number line at the top to actually show this thinking. 9 plus 5 equals 14, and then 14 plus 1 equals 15. We had someone who first started by adding the 5 and the 1 together, and then added that onto 9. And then you have an example of the make 10 strategy, where a student noticed that 9 plus 1 made 10, and they could easily add 5 on to make 15. So we're getting a whole bunch of strategies that are appearing as we discuss these numbers. I'm going to briefly show you an example of a subtraction. So let's see if I can do this. And is it up?
Yep.
Yes.
Okay, so this is an example of a subtraction number talk. Once again, actually, this was a number talk I did today with second graders. And in this problem, I actually used a word problem context, because subtraction, especially for younger children, is sometimes hard for them to conceptualize. So I used the experience of walking laps in my yard, and how I wanted to walk 30 laps around the yard, and I have already walked 24 laps. How many more laps would I need to reach my goal? So here you see the expression is on the board. You'll see examples of the number line up here quite a bit. It's not that the children were using the number line, but the number line is incredibly helpful for showing what a child is thinking. And so the one situation to the left, you can see a child started at 24 and said they added 3, and they added 3 again until they got to 30, and that's how they knew the answer was 6. Another child, towards the bottom, started at 24 and just counted up by ones. You have another child, this is very interesting, started at 30, subtracted 10, and then added 4 to get to 24. And so they said they knew 10 minus 4 was 6, and that's how they got the answer 6. We also had this situation where a child said, I know 4 plus 6 is 10, therefore I know 4 plus 20 is 24. Oh, wait, yeah. So therefore I know 24 plus 6 is 30. He used that as a landmark number and used what he knew about making 10. Just lots of really interesting strategies there. Let's see if I can turn it off somehow.
Yes, it's off. It's back on.
It's off. Okay. All this technology is a little new and different. Yeah, basically, often you have a thread of problems, and there may be 3 or 4 different problems that are related to each other that you may do at one time. And this is supposed to be a pretty short activity, like no more than 15 minutes. I'm still getting better at that. I've gone on a little longer than I want sometimes, so I'm learning how to shorten them up. But the idea is that you do a little bit frequently and give the children just this really rich experience to talk about their mathematics. And the added bonus is that you are easily covering about half of your standards of mathematical practice when you engage in this activity, such as reasoning abstractly and quantitatively, constructing viable arguments since you're defending why you chose a certain number. Often you're modeling, you're attending to precision with your language, and you're making use of structure and repeated reasoning. So all round, I'm finding it a really wonderful activity and something deserving of anybody's time to learn more about. So I know there's lots of other strategies out there too, but
yeah. Julie or Chris, do you want to add any other strategies you may use? Or
we do a lot of talk in 5th grade, particularly about what do you know when you go to solve a problem, whether it be a word problem or just a straight computation problem, and then where does that take you? So we have students demonstrate either with their partner. Well, for example, we are doing angles now, and some students may be able to articulate, well, the exterior angle is equal to the sum of the opposite interior angles. Some students have to go through finding each of the interior angles and then subtracting the exterior angle from 180. And in my class, I allow all of those different strategies to be verbalized and talked about. One of the things that we work really hard on is respectfully disagreeing. So I will let a child solve a problem incorrectly. I know that they're going incorrectly. I see where their thinking is falling apart, but I let them go to the completion of their thought process. And then we'll say, do you agree or disagree? And a student will say, I disagree because, and then they'll go and they'll explain their thinking. And then someone else may say, well, I disagree with both of you because, and there's some other thinking. So we bring that conversation into our math on a daily basis. And that has been really powerful as far as children being able to verbalize what they think about math, as well as try new strategies that they may not initiate on their own.
Yeah. That's great. Thank you. Thank you so much, Chris. Julie, did you want to share anything from a primary perspective?
Yeah, I think in the primary world, just getting to children through what their interests are, and there's so many manipulatives you can use and so many stories about themselves you can use for counting and cardinality and number sense and all those other operations. And so I think that using that, especially in word problems, helps children really engage in the lesson, and it's a strategy for them wanting to be able to learn counting and become more involved with it.
Great. Thank you. So in addition to number talks and some of the other things that you all have described, there are lots of other ways to make math really exciting and make it come to life, right? Chris, can you talk a little bit about the strategies that you use in your classroom to make math more real world and connected to other disciplines?
Well, one of the things that I do and have always done it is make word problems relative to the kids. So I will rewrite them. I use students' names. I use the adults in their lives' names. You know, in making challenging word problems, it'll be that, you know, myself and Mrs. Roykoff are buying sheep. We're sheep farmers. And, you know, the kids think that that's hysterical that we are sheep farmers, but it's a real-world problem connected to important adults in their lives. We were doing fractions, and one of the word problems I came up with, they know I have 3 sons, you know, so Shane can do it at a third of the lawn in an hour, and Sam can do it in a quarter of the lawn in an hour, and Simon, he can only do a sixth of the lawn in an hour. But I need my whole lawn mowed. How long is it going to take for the 3 boys to finish it? The other thing that they have found very exciting this year is I give them the answer. So I give them a very challenging word problem that relates to something in their lives. We did a unit on engineering design with bridges. And I gave them the answer of how strong a bridge was. This is what, and they had to tell me, they had to prove it. You have to prove to me how you can demonstrate that this bridge is actually this strong. And so I think for them that was engaging and frustrating, and it got them talking with their peers to really solve some real life situations for them. We did that when we were doing the big numbers, you know, to the what do we do? We go to the billions, 100 billions this year. So, so that's just stuff that we do on a regular basis, and then we share. You know, I share that information with my colleagues. So the sheep problem, I had a student from another class say, Mrs. Barley, you're not going to be here next year. You're going to go own a sheep farm? And I said, no. It's just an example of something that we're going to do. The other thing that really helps my students particularly stay engaged in talking about math in their real life is when I share what I call Barley stories. So I'll say, I woke up in the middle of the night, and remember when we were trying to figure out that problem, and we figured it out this way? Well, I figured out another way. And so they'll groan, and they'll say, you're not going to be talking about math at morning meeting again. I say, yes, I am. So letting them know that I think about math a lot, even when I wake up in the middle of the night. Or I'll say, when I was walking the dog this morning, I noticed something, and how can we figure that out? So really bringing that into the classroom in a way that they find fun, engaging, and as 5th graders, right? It's like, oh no, here we go again. You know, you're going to make us do math at morning meeting. Well, yes, of course I am, because I figured out a new way to do it. So that I think for them keeps it connected to themselves as they're learning really for 5th grade difficult concepts.
Thanks. Other panelists, join in.
I could talk, you know, in terms of other activities. All of Chris's examples are wonderful. In terms of some other things that I do is cooperative activities with children and having them have some sort of goal the group needs to solve, often assigning tasks to different group members to facilitate the process, doing that in small groups or doing it with a partner, opportunities where the children have to talk to each other. And providing that is just part of the process to help the learning along, because it's not enough for children just to hear about something. They actually have to engage in it and experiment with it and practice with it to make it stick and to make it theirs.
Yeah, absolutely. And apply it. I mean, that's you know, number one, that idea of transfer. So if kids can take what they know and transfer it in a different context or in a different setting or with a totally new, novel problem, then like, wow, yeah, we know that kids have really gotten it, which is great. Thank you. Liddy.
Yes, we are ready. So we're going to keep on moving. Ithaca teachers collect a variety of data, from district benchmark assessments to Singapore math unit tests, and our own information obviously gathered from in-class work with students. Would you talk a little bit about some ways, some forms of data that you use, and how you use the data to help you plan for whole class, small group, and individual mathematics instruction? Jane, you want to start us out with that?
Sure. One of the things that I find actually most valuable is just looking at students' daily work that they have completed on an independent basis. So it's not something that I've totally guided them through, but it's sort of that follow-up. We've done something and now I'm letting them practice, but then I'll collect their practice to see if they at least made that much of a transfer. And especially working with students who struggle, I found that incredibly valuable, because sometimes I thought I was just being oh so clear that obviously I wasn't being as clear as I thought to at least one or two of the students, or they still had some type of confusion that I had not gotten through. So I find that immediate work, so then I can replan the next day's lesson and address wherever the error pattern is still existing.
Great. Julie, how about collecting data in the dailies?
I think that a lot of that, I like at times to just have time to observe the kids. So when I'm doing the dailies and I'm taking out of the rotation, it gives me time throughout math time when I can get up to observe what the kids are doing. I also have them with Math by Myself complete work that I can look at later that they've been working on independently to see how they're doing. I also keep data of the group work that they do, you know, how many times we've worked on the skill, and if they are successful at it during the daily time when they're doing their Math by Myself.
Great. Chris, any other ideas?
Yeah, we use all of the different things that you mentioned, as well as conversations, little interventions that the team comes up with. One thing we've also kind of rolled into this practice is the student self-assessment. So if they're doing their, for example, Jane, you know, collecting their, okay, this is our practice by ourselves, teacher looking at it and then conferencing with the student and saying, okay, where did you fall apart? Is it your facts? Was it computation? Did you just not know what was going on? Were you confused? You know, or did you just not read the directions? So helping students self-assess and really look at their work to see where they are strong and where they're falling apart. So then they can set goals and target, oh, you know, it's computation, that's my 6 facts, I really got to work on my 6 facts. This is the 3rd time I've gotten a problem wrong because I don't know my 6 facts. And so as far as us collecting data and talking about students and making those transitions and changing through grouping, you know, some students may be able to multiply multi-digit numbers fluently and other students still don't know their facts. Well, in doing our skill-based group, the way we approached instruction for those two different groups, the individual who had them was very different. But yet, when they take their unit test, they're still doing a self-assessment of, okay, I got it right or wrong, where did I fall apart? Could be facts, could be I just made a mistake, you know. So that's, I think, an exciting thing that we added into this looking at data process, and particularly reflecting with students on that self-assessment piece so that they are an active part of their math growth, I guess.
Well, and that's how we make them lifelong learners, is when they are able to be reflective and set their own goals. And that's how we get the most important part of the process of using data, is getting the kids involved in it. And it's a wonderful example to hear about. Thanks.
It's funny, I was just thinking about that too. This morning when I was reflecting on, you know, coming to the session and helping to lead the session, I was thinking about my days in the classroom that I often, you know, miss very much. But I think about, you know, what what I left off doing and what I would start doing if I were back in the classroom. And one of the things that that I did with my small groups was, so each of my small groups, they changed. Sometimes they changed every week, but in general, they stuck around like one pretty common goal for like about 6 weeks or so. And so, for example, if I had a group that was really working on understanding adding by tens, I might, it was clear to them like why they were there with me for that like 10-minute intervention or 5-minute small group. Like they knew what their goal was, and they could talk about like how they were doing progressing toward that goal. But what I found was I wasn't really precise with them. Like they knew that was like their long-term goal, but if I could go back and do it all over again, I think I would either sort of shift those goals or chunk them up a little bit so that they had really specific language to talk about, like, so right now I can do blank, and so it could be really clear to them, and like in order to get to this next place or this next spot or this next benchmark, I need to do X. And so we were moving in that direction, and I wish I could go back and get more to it. So.
I think that specific language is really important with learning targets, and that's what I can't wait to get back to do too, so that kids know exactly what the expectation is.
Yeah, and having used learning targets consistently and reliably this year with students, the thing that we found is that students can also set their own learning targets. So when you're writing on the board for today, examples, today's learning target was I can use multiple strategies to find the measure of angles in a triangle. We call them mystery angles. We're detectives. We are finding the measure of the mystery angle. And so they can then set a more specific learning target if they're struggling with a strategy in which we have taught. If they're struggling with a specific strategy, that may become their individual learning target. So the I cans are really powerful. And I see particularly with 5th graders where that is moving them towards that, setting their own goals and moving themselves forward as mathematical thinkers in a way that I may not picture for that particular child.
Yeah. That's pretty cool, that level of understanding about their own learning, and that level of metacognition is pretty awesome. Well, ladies, we want to thank you so much for joining us today. Chris, Jane, and Julie, it has been a pleasure. You are extraordinary educators. Thank you so much for sharing your time with us and your experiences with everyone in the Ithaca district. We appreciate it. If you want to watch this later, you can, of course, if you go to any of the staff tabs on the district website and click on professional development website, it'll take you to everything that's archived. And you can always comment on something later and we can get it to the panelists afterward. Ladies, if you want to say one last thing, you're more than welcome to. All right.
Yeah, I will say, my students all know that I love to teach math, and they will say, Mrs. Barley will teach us math every day, and I really hope that I give them the message that math is throughout their day. It's a part of their reading, it's a part of their writing, it's a part of their thinking. And if that's what they leave me with, then I've done something good.
Yay.
Absolutely. Agreed. All right. Well, thank you so much, Julie, Jane, and Chris. We appreciate it, and we'll see everybody later. See everybody next week.
Okay. Yeah, see you next week.
Bye-bye.
Bye.
Bye.